Okay, 11.8, they want us to determine the points of intersection. So let's use equal value method. They're both set equal to y, so that means they both equal each other, right? So we have x squared plus x minus 9 equals 2x minus 3. We subtract 2x from both sides, so I get x squared plus 1 minus 2 is minus x. Minus 9 equals negative 3, and then add 3 to both sides. X squared minus x, add 3 minus 6 equals 0. Now we have a quadratic equation, right? So ultimately, I would like to solve this in the quickest method possible. Factoring is always the quickest if it's possible, so let's do it. So we have x minus 3 times x plus 2, right? Because negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1, so the middle term works. Okay, so zero product property says x minus 3 is 0, or x plus 2 is 0, x equals 3, or x equals negative 2. Now, don't stop here. This is where everybody makes the biggest mistake. You did all this work, but you didn't answer the question. They want the points of intersection. They want an ordered pair. Remember, these graphs, I have a parabola and I have a line, right? We want these 2 points of intersection, that they are ordered pairs. So I have the x values. I need to get the y values. So I'm going to do it for x equals 3 and x equals negative 2. To do it, I need to substitute it into either of those two equations. I'm going to pick the linear. It's easier, right? So for this one, I got y equals 2 times 3 minus 3. Y equals 6 minus 3, y equals 3. So the first ordered pair is 3, 3. The second one is y equals 2 times negative 2 minus 3, y equals negative 4 minus 3, y equals negative 7. So this one is negative 2, negative 7. These are the points of intersection, right? The points of intersection.